In our pursuit of this thing, which is the variable hypercycloid, we actually looked at this, which is a rack mechanism that converts the reciprocating motion of the rack into a continuous one-way motion. Now, one-way rotating motion. Now, it does have a problem. The problem with this is that slide needs to travel its full distance, and of course we need it variable if we're going to use it with the variable hypercycloid. Now, it turns out doing that isn't that difficult, and all it really needs is a couple of ratchets. So of course I turned Tinkercad and drew this up. All you really need to do is print that out and put it together. So here it is printed out. The pole gets glued onto that gear centrally, it doesn't matter which side, so it's like that. The actual ratchet itself is integral to that, and it just slots on like that. And there are two of them we need to make so that they're like that. Both of these go onto this pegged one here, like that, one on there, with the ratchet down and the pole up. The two ratchets go into that longer, larger section there. That slots on there like that. The central one with this little piece goes in there like that. There we go, and then we put the cap on top like that, and that gets shoved in the middle and is going to be the bit that we push backwards and forwards. Right, I've put a little dot on it there because that's the output, and as I push this backwards and forwards, you should be able to see that dot only moving in one direction. That's pushing it all the way. If I push it a short amount of way, of course, it only moves a little bit because it's variable like we want it to be. So the distance this move is dependent on the length of that stroke, and that's exactly what we wanted. It's also pretty compact and neat. Now we've put that together, this is what we get, and as we've seen, all I really need to do is push that backwards and forwards, and we get a continuous rotating motion that varies on the distance that I push that. If I push that only a little bit, of course it only turns a bit. Push it a long way, it turns a long way, which is exactly what we wanted. Now unfortunately, of course, it does sound a little bit like a field full of crickets at mating season, but it works. You can do something about that with these. What these are one-way bearings. They're actually the same size as skate bearings. Here's a skate bearing. It's 22 millimeters outside diameter, 8 millimeters inside diameter. Skate bearings are 7 millimeters thick, and these are 9 millimeters thick. And they do exactly the same thing as the ratchets, only quietly and much more accurately. You can get these with zero backlash. Now I bought these. You can print them if you want to, and there's various designs on Thingiverse for actually doing it, but these ones are industrially made and incredibly accurate. And so we can reprint this entire thing, but with a space in it to fit the bearing, and that's exactly what I've done here. Instead of having a ratchet in the centre there, it has an indent to take that bearing. So the bearing fits in there, there's an axle that will go through there that will fit in the inside of that bearing, and it'll do exactly the same job as the ratchet. So let's put that together. So that's them drifted in and the axle's fitted. That axle doesn't extend all the way through there, it stops at the bottom of here, because this one also has an axle in, and that axle fits in there like that, with the one rotating around the other. But you're best off, before you put them together, of dropping them into this retaining ring and then pushing the axles in like that. And there it is together. So let's push it in. That's awesome! You can see, I've put a dot on it so we can see it, and as I pull it out, it turns clockwise. As I push it in, it turns clockwise. So we get a single direction of rotation, even though that's been pushed in and out. And of course, it's much quieter and much more accurate because I've used those clutch bearings. So we've gone from this basic mechanism where we needed the full stroke to actually get this to rotate in the same direction, to this version, which was the ratchet version, where we could push it up and down and still get the same rotation, to this final version where we used clutch bearings to get a much more accurate and quiet version of it. And here now we're able to turn this linear up and down into a single direction rotation. And you've guessed it, it's based on something in this, Hitchcock's Mechanical Movements, Devices and Appliances. It's actually device number, says here we go, 976. In 976 they used bevel gears, and you'll have seen that bevel gear arrangement before because Maker's Muse did something on it. All this is that bevel gear arrangement, instead of being bent around, laid flat. But that is what we're going to use to rectify our motion. I hope you enjoyed the video. Thank you very much for watching, and please do remember to like and subscribe.